Good morning, everybody. So let us start with a session. So now we have a keynote lecture by Dr. Sudarshan Ghosh Dastidar. He'll be speaking on the evaluation of IVF technology in India. So I would like to invite Dr. Sudarshan Ghosh Dastidar, sir, on the dais. So sir is the director of ART at IPGMER Hospital, Kolkata. So welcome you, sir.
A very good morning, everybody. And I must thank Dr. Sujata Kaur for inviting me for this keynote session here. A subject very close to my heart. I am with the subject for this 44th year, and the development of IVF in India, especially in reference to Kolkata. That will be my presentation today. And so evolution of IVF technology in India is a fascinating story. How it developed from a very scratch, in spite of a lot of odds, and interestingly, almost contemporary to the rest of the world. That is most important. And before we go to actual IVF development in India or what we are doing, based on some pioneering work of first Dr. Gregory Pincus, who demonstrated that if you take out the oocyte from the follicle, you culture them in vitro, they will grow. And then Wheaton, who showed 2-cell embryos to be grown to blastose stage. And lastly, Dr. John Biggers, the boss, the father figure of mammalian embryology, who passed away recently. He showed that different aspects of culture media, tissue culture media, role of pyruvates, lactate, intermediate metabolisms, and he discovered the osmolarity on the critical role of osmolarity. I'll talk later. And then, of course, the main figure in the field, Dr. Robert Edwards, he worked real hard from 1956 and till 78, when they had the first baby. And he developed a lot of things like maturity, media, and so on. And second man from India, Dr. Subhash Mukherjee, with whom I had my first training. As a student in 1974, I was trained by him on sub-endometrial protein in 1977. So I was inducted in the field by Dr. Mukherjee. So my friend, my teacher, my guide. And then lastly, Dr. Palermo, again a good friend of mine, he first reported intracytoplasmic sperm injection. I would consider a revolutionary step in male factor infertility. So in chronology of IVF research in India, if you think Subhash Mukherjee, 1978-86, in Mumbai, Dr. Hinduja Anand Kumar, they reported a baby. And in Kolkata, we worked 81-86. Dr. B.N. Chakraborty, he just passed away, and myself. And we delivered a baby 86 November. Soon after, there's a baby by Dr. Sadhna Desai and her group, and in Mumbai. In IUI, we delivered the babies in 1982-83. And in ICSI, there's a baby by Dr. Firuza Parikh from Jaslo Hospital, I think. It was 1995, 2-3 months before to our baby by ICSI. So these two groups worked on ICSI initially in India. So development of IVF, our initial struggle, how we started and how we finished, is a fascinating story because we started from zero. Almost no technology, no knowledge, no paper. You can presume there's not a day of internet. So you have to work from zero. So there's no CO2 incubators available, tissue culture grade media, plastics, disposables were not available. And even ultra-sterile work environment was not very difficult to develop. And thus, we used to face frequent contamination in the culture in our initial attempt in 1981-82. And in Kolkata, in 81, there are frequent power cuts. Thus, we have to arrange alternative generators to run our incubators. And the other basic challenge was at that time, you may laugh or it's funny that we didn't have seen how oocyte cumulus corona looks under dissecting microscope. So there's no photography. in the literature. So myself and Dr. Chakraborty we never seen, and we had to start from scratch. And so major scientific and technical challenges in the IVF technology in India, ovarian stimulation, clomiphene HMG, monitoring ovarian response. I'll talk about that a little bit. But my responsibility was the laboratory to set up a basic embryology laboratory, preparation of culture media, osmolarity control, as I learned from Dr. Biggers, gentle but speedy handling of oocytes and embryos, very, very important till today, and IVF and embryo culture and basic quality control. You all appreciate now, without a basic quality control, rigorous quality control, you can't have sustained results and good pregnancy rate. So this was my basic laboratory in my house, where I was just trying to understand, look at the oocyte, identify the oocyte, and prepare the culture medium in the initial part, 81, 82. And at that time, to monitor the ovulation, we had a basal body temperature, cervical mucus study. Hormone assay was done by radioimmunology assay in Kolkata, but reports were available only after 3 to 4 days. So clinical monitoring was most important. But then there's a paper by Dr. Insler, V. Insler. He reported cervical mucus scoring showing a typical farning pattern, etc. A simple pattern, but it could help you in understanding the estradiol exposure, ovarian response, and ovulatory status. So I followed that very closely, and the score was maximum 12. So that was our armamentarium, but I modified the score to a little bit simplistic way. Spinberg height and mucus stretchability and a hanging drop score. We presented in Fadley Study 1986 in Singapore. That was a paper about the follicular maturity monitoring by cervical scoring based on Insler score. So initial phase, laparoscopic oocyte retrieval. You all know initially till 1985 until Dr. Kemeter and they developed the transvaginal sonography, we were doing laparoscopic retrieval. Dr. Chakraborty used to aspirate follicles laparoscopically from Central Calcutta nursing home. And early attempts to identify oocyte, that was the main problem. And I used to try, we didn't have a laboratory. So after from the nursing home, I used to take the follicular aspirate to Jadavpur University to see the oocyte. Yes, that was the challenge then. And thus I learned by simple trial and error method to identify and isolate oocytes from blood mixed follicular fluid. Though it appears the most simple step in IVF lab today, it took nearly several weeks to learn that and master that. So it was my early photographs. Dr. Mukherjee was blamed. He committed suicide because he didn't have a photograph. So in my first, one of my friends from Kharagpur IIT, he arranged a photograph by attachment with the objective, and thus I took the photograph. The first one you must see that it's a degenerating oocyte, almost degenerated, and the second one maybe midway, metaphase 1 or GV. The last one most likely a oocyte surrounded by cumulus coronus complex. These photographs were taken in 1981-82 with a very simple microscopic system. Unfortunately, Dr. Mukherjee couldn't take that and had to face a lot of criticism for that only. So in 1983, I came to know Dr. Lucinda Fick's publication of a book, elegant book on oocyte maturity. First one, M1 oocyte and small dark oocyte, coronocumulus complex you can see. The right one, the metaphase 2 oocyte, expanded cumulus, corona radiata, and zona transparent. And the bottom one, you can easily see it's a clumped, darkened clumped corona cells, also the cumulus cells. So it's a post-mature oocyte, unlikely to give rise to good quality of embryo and pregnancy. So these are the early things, but I must say that the early part of the IVF work, whoever worked, I don't know whether there is anyone in this hall here who worked in 81, 80s, there was hardly any information. So here depend on animal experimentation. There are a lot of animal experimentation. Trust me, before 70 years, almost everything was done in rabbit. Everything. Fertilization, embryo culture, blastocyst culture, everything was done. And so I had to depend on then setting up the basic laboratory, methods to identify. But I was greatly benefited from an elegant chapter just put on my first part of the write-up by Dr. John Biggers from Harvard. He presented with all details about tissue culture media, its quality control, the need for sodium pyruvate as a energy substrate, and also he discovered osmolarity control as a very prerequisite for good fertilization and embryonic growth. So Bigger should be recognized for that. And I gratefully acknowledge also the great support from last line, Dr. J.M. Bedford, who was the pioneer and mentored my training in Cornell University in 1986. I was there February to June to study the quality control of culture media, fertilization, early events, and human embryo growth. So there's some knowledge gap in 81, 82. As you can understand. So after oocyte identification, my next challenge was to try for IVF documentation of fertilized oocyte by 2 p.m. Difficult job then. How to assess oocyte maturity before you fertilize. This was very important then at that time. It is still important till now. In IVF, I'm not talking about ICSI, how to assess oocyte maturity. So it needs some time for pre-incubation. So Dr. Subhash Mukherjee told me, it was ready knowledge to me, in contrast to others. I knew from him in 1978 that 4 to 6 hours pre-incubation of the oocyte is needed before you add sperm. Mind it, after sperm addition, the further maturation may be hindered, may be stopped. So 3 to 4 hours based on your oocyte quality. Sperm washing and sperm swim up, sperm capacitation is a prerequisite for mammalian fertilization. I missed the slide, reported by Chang and Austin in 1954, long back, that you need to wash them and put some media or in the vaginal or in the uterine cavity for capacitation to take place, before which fertilization cannot take place. So these are very knowledge gap and some of the elegant finding for some big workers, some pioneers, based on which our work was based. And tissue culture media development again on rabbit work and mouse work, thyroid solution 30s, oil solution 49, Biggers the main solution 1965, where he added the sodium pyruvate along with higher amount of sodium bicarbonate for the pH maintenance. Then Menazo-B2 medium, I think the first medium came to India as a prepared medium in 1994. Before that, I had to prepare my own media. And then finally, we worked with Hamseptin media in our state. So it is the initial tissue culture media, you can see. The second part, you can look at the blue color. Dr. Biggers added sodium bicarbonate 2.1 gram, little higher, to maintain the pH. So it was also elegant study by him. So I based on Dr. Biggers' medium, and he showed us that around 280 to 286 milliosmol, you have to maintain your media. In fact, if even today your prepared media, if you have osmometer, then you should check some of the medias, commercial medias, are not at the desired range. So you have to maintain that. So it was a major breakthrough by Dr. Biggers from Harvard, that the osmolarity of the media is a very, very critical point to have good fertilization and embryonic growth. And then this was my tissue culture media preparation 83 onwards. You can see left first slide, media preparation, in the plastic, dual chambers, then filtration by millipore filter. You can see the second one in the bottom, sterilization through media filter by Nalgene filter. So you put the media on the top and filter through the bottom. That was the thing I used to do in 1983, 84. And in right hand side, the advanced osmometer, we got the osmometer only in 1984 on our way back from Helsinki conference in Finland. So after that, we had a good result in embryo fertilization and embryo development rate. So this is very important again. At that time, we were not getting pregnancy in 1984, 82. No pregnancy. We were very frustrated. Dr. Chakraborty was very frustrated. We are going to stop IVF program. But by that time, I intuitively put class 1, 100% motile sperm in the uterine cavity. I think possibly that was the first batch of pregnancies following IUI reported in 5th World Congress, Human Congress in 85. The pregnancies took place in 80 to 83. I reported that. Unfortunately, we didn't publish at the full paper. Dr. Chakraborty was very reluctant to publish those days. I don't know why. Because of Dr. Mukherjee's fate, maybe. So this was possibly the first group of pregnancies. And this was the first paper of our abstract. I named it in vivo in vitro insemination. Even the term was not coined as IUI till 1984. It was coined as in vitro insemination. I presented in the 5th World Congress. And thus we were developing. And then from my way back to Helsinki, I was grateful Dr. Bob Edwards, wonderful man, you all know, he was awarded a Nobel Prize. He told me that you should visit Bornhall Clinic. And in Bornhall Clinic, earlier days, Dr. Edwards was also using a desiccator flushed with 5% CO2 air and placed inside an ordinary 37-degree incubator. So it is a very, very basic setup in Bornhall, even in England. And this was a tremendous moral support because the incubation system I developed was more or less similar. So IVF embryo culture, glass tube, culture dish or microdome. Initially in tubes, I didn't get the right kind of plastic dish. From 1983 onwards, I started microdome fertilization under liquid paraffin. So development of improved embryo culture. So my next challenge, it's a challenge really. You might be thinking, what is the challenge? There is no incubator in Calcutta, no CO2 incubator. So I had to develop a system which will produce 5% CO2 incubator CO2 in 95% relative humidity. So I tried several systems. Finally, one company from Calcutta developed the right-hand side, the system, a simple system which can stand autoclaving. We developed earlier, but that was breaking up to autoclaving. So they developed a system which can stand autoclaving, and it was supplied through by the left-hand side, you see the picture, 5% CO2 in air from cylinder. And that was a system through which we got very high pregnancy rate and the first live birth from this system without a CO2 incubator. This should be noted. So we recorded all the 2PN fertilization, even the last one 3PN fertilization. So now we are on a good way of working. Our system was much better. And after many failures, we achieved fertilization oocyte up to 8-cell stage, July 83. And following embryo transfer, a pregnancy occurred in 1983. So it was a major breakthrough because we were frustrated. And we could understand the feasibility of IVF. We presented the paper in 3rd World Congress on IVF, Helsinki, Finland, 84. This was the first report of successful IVF and embryo transfer, resulting in a pregnancy to be reported from India in a World Congress, as reported our experience. So this was there I met Dr. Edwards, the picture myself, Dr. Edwards, in the center myself, and right side Dr. Marcus Sepala, the chairman, 1984. This is the man, amazing, Bob Edwards. Developed everything, trained everyone, very open and very helpful. I had no reference, but he did everything for me. And it's a nostalgic picture. Many of my audience, I like to have your interest here. I'm standing a very bad camera. I'm standing in front of the convention center. On the previous day, I saw there are 13 flags just in front of the convention center. There is no Indian flag. I asked the organizer. They said it is a flags of those countries who are presenting paper. I said, we are presenting paper. He said, yes, this is Finland people. So they called their chairman, Dr. Marcus Sepala. He arranged to get the Indian flag from Indian High Commission. And before the next conference day, next day, they hoisted the Indian flag in front of me. And that was my great point in my life. So another my fond memories with Dr. Mohinder Parikh. You all know him. He visited us in 1985. He's the founder of the ISER. And he's seen here discussing with me about my laboratory. He has seen my laboratory. He was a great sympathizer and a supporter of my work in those days. And let me my tribute to Dr. Mike Bedford of Cornell, with whom I worked in 1986, January to June. He showed me the quality control, Bob Edwards. And the right side, Dr. Brish Saxena. He's an Indian, but is the top guy in Cornell Medical Center, with whom I worked for hormone assay. Our final success, we had a baby in 1986. That is, we knew that a baby is going to born, and we worked nearly 6 years by then, myself, Dr. Chakraborty, and that was the second baby of Kolkata after Dr. Subhash Mukherjee, reported in a wide manner in all the newspapers that time. One reporter called it Immaculate Conception. Umesh Anand, now he's the top man in BBC, and he was with me for 1 month following my work. He stayed with me 1 month, every day following me, what I'm doing. This is the reporter, Umesh Anand, I still know the name. Myself, Dr. Chakraborty in the laboratory. And then, to the best of my knowledge, ICSI was the next workup started in my center in Jaslok Hospital, Mumbai. Dr. Firuza Parekh, my good friend. So it was my work and Dr. Firuza Parekh. And that was the first baby by Dr. Parekh and second one by me in 1995. So we were very close to Palermo. He started in 92, I started in 93 and delivered baby. And this is the hands-on workshop. I think it's the first. I was trained by Dr. Koyama in Tokyo, in Japan, and in 2010. And he agreed to come with all his team. He came there, and you can see throughout India, everybody came here to learn about vitrification in that workshop. So development of IVF in India is a fascinating story of scientific research in Kolkata, India, almost contemporary. I again repeat, almost contemporary to the rest of the world. This is the only research. India was very, very contemporary to the rest of the world. And pioneer of IVF, Dr. Mukherjee, unfortunately, was not properly recognized at that time. Dr. B.N. Chakraborty and myself started the second phase of work in Kolkata, 1981. And I was entrusted with the responsibility of developing IVF laboratory, which I worked for 6-7 years. Being a close student of Dr. Subhash Mukherjee, this was my benefit. I learned a lot of things before everybody. In fact, when I went to Helsinki, Bob asked me, how do you know all these things? I said, Dr. Mukherjee taught me as a student in 1977. So I know. Our struggle to develop the technology IVF is a testimony that many advanced research starts with a humble beginning, very humble background. With proper motivation, good teamwork, and dedication leads to success. And that's the story of scientific research. And I must say thank you to all of you for your patient hearing. Thank you from...
Thank you so much, sir, for sharing your success story. And I think it's an inspiration for every one of us. And we really appreciate the great effort because of which we are what we are today. So thank you so much, sir, for sharing this story with us.
Thank you, Dr. Ghosh.
Yeah.
It looks very ancient, but since we belong to the same era, I can correlate with you,
Yeah.
how you came up. So we should not forget our roots.
Terrible.
And we should pay a great tribute to Dr. Subhash and Dr. B.N. Chakraborty, and who was the pioneer. And we must not forget how we started. See, media preparation. When I also started developing interest in IVF, so my main thought was, how will I prepare media? So used to keep reading, you put this. So hats off to you. You have been wonderful, and very nice to hear all this story from you. Thank you.
Thank you. I would like to have any questions.
Thank you so much.
Thank you.
Yeah.